Hello 3D printing friends! Today on the BV3D channel we're going to take a look at the Sunlu S8 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi everyone, welcome back. Hey, if you're new here and you want to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're taking a look at the Sunlu S8 3D printer. Yes, Sunlu. Yes, that Sunlu. Yes, the Sunlu that sells Filament. No, that's okay. I didn't know they sold 3D printers either until very recently. This particular Sunlu S8 was an Amazon customer return, and this was sent to me by Rebecca at Sunlu. And now here's the backstory on that. At the beginning of March, Sunlu tweeted about having 2 customer return printers and basically asked, anybody want a free printer? So I said yes. Well, what would you have said? Now, because it was a pre-owned printer, I had no idea what to expect of it. Why had it been returned? Was it defective? If so, what was wrong with it? Had it been misused by its original owner? Had it been run over by a truck at the shipping facility? This was all unclear. Now, I'm reasonably confident in my ability to get a broken printer working again, and I figured if I was getting this printer for the sum of $0, I would be happy to take a chance. If nothing else, I'd have a nice pile of parts that I could try to build something with. Anyway, I had a short DM conversation with Rebecca, the person behind the Sunlu 3D account on Twitter. When I responded to that tweet about the returned printers, I didn't actually expect to get one of them, but about a week later, UPS rang the doorbell and, well, here it is. So I opened the box half expecting to see a mangled printer haphazardly stuffed inside, but I was pleasantly surprised to note that it didn't look like the printer had ever actually been taken out of the box, at least not all the way. As I started looking it over, I noticed that the big zip ties holding the gantry to the base were still attached on one side, and looking in the bag of parts, the bolts that secure the gantry to the base didn't look like they'd been used. All in all, the only actual defect I noticed was the small metal lever had come off of the X-axis limit switch. So I don't know why the printer was returned. Maybe the person who bought it started to take it out of the box, snagged something on that little limit switch, and popped the lever off and they panicked and returned it. Or maybe just as they started to get it out of the box, their significant other walked in. You bought a what? Nope, you send that thing back right this minute. But whatever the reason for its return, that's what I found. A printer that was basically brand new in the box, with the only problem being the X-axis limit switch. And the missing part of the switch was floating around loose in the box, so I reattached it. It just snaps in. I don't have a video of me assembling the printer. Like a few other 3D printers available these days, it's already almost completely assembled. It's literally a matter of using 6 screws to attach the gantry to the base, and then you can adjust the nozzle height and start printing. So here's what I intend to do in this video. First, I want to quickly go over the printer's specifications. Then, I want to talk about the printer in a little more detail, and then I want to talk about my initial impressions of the printer so you'll know what I think is good and what could use some improvement. So let's go ahead and dive right into the specs. The Sunlu S8 is now the largest 3D printer I own, with a build volume of 310mm by 310mm by 400mm. It is a single extruder printer with a Bowden-style feed system, which consumes 1.75mm filament and squeezes it out of a 0.4mm nozzle. It also has a filament runout sensor. It has dual Z-axis stepper motors and lead screws, which keeps the X-axis from sagging. That can sometimes happen on printers that have only one Z-axis stepper motor and lead screw. It has a 24-volt, 360-watt power supply with an always-on cooling fan. It has a plain glass build surface. The spool holder is an acrylic A-frame design which does not attach directly to the printer. It has a 128 by 64 pixel LCD panel with a control knob, and the main board is an 8-bit board with integrated 4988 type stepper motor drivers. On the front it has a micro SD card slot as well as a standard USB type B port. It's running Marlin and has thermal runaway protection and power loss recovery enabled. Its overall size is 600mm by 490mm by 640mm, or about 2 feet deep, a little over 1.5 feet wide, and a little over 2 feet tall. Okay, so there you have the printer's specifications. Now we can just kind of chat about the S8. This printer seems to be very similar to other large format Cartesian 3D printers in terms of build volume and features. But unlike many of them, which have their electronics in a separate enclosure, the Sunlu S8 has its electronics mounted at the front of the printer. This certainly makes it easier to move the printer around because you don't have two separate components connected by cables, but it does add to the overall depth of the printer. Because the power supply is mounted in the electronics compartment at the front of the printer, the AC power socket and power switch are in an unusual and somewhat awkward location. They're here, right behind the LCD screen. And I'll talk about the safety implications of that a little later. Now, interestingly, this configuration makes it incredibly easy to access the electronics. By removing 3 screws on the front of the unit, the cover simply lifts off, exposing the printer's power supply and its mainboard. Also, there seems to be plenty of room inside for buck converters if, for instance, you need to step down the printer's 24-volt supply to 12 volts for LEDs or to 5 volts to drive a Raspberry Pi running Octoprint. As roomy as it is, though, I don't think there's a good place to mount a Raspberry Pi inside the case. Now, with regard to its construction, the Sunlu S8, like many 3D printers these days, is built from V-slot aluminum extrusions. And like most printers built this way, it uses wheels, which ride in the slots to constrain the motion for a given axis. Now, these wheels are usually in a triangular arrangement with 2 wheels on one side of the aluminum extrusion and 1 wheel on the other side. And that 1 wheel that's all by itself on that side of the extrusion is adjustable by means of an eccentric nut. Turning that nut adjusts the distance between the wheel and the extrusion. The big heated aluminum bed is insulated from below, and the plain glass build plate is attached to the top of the bed by 4 binder clips. The bed adjustment knobs are not as large as those on Creality printers, but they're also not super tiny like they used to be on printers just a few years ago. These are mid-sized knobs. They work and they're easy enough to turn, but I prefer the ones on my Ender 3 and Ender 3 Pro. Speaking of the bed and the knobs, this printer is manually leveled. There is no optional kit from Sunlu for adding a bed probe such as a BL Touch. I mentioned earlier that the printer is running Marlin, and Sunlu has the configuration.h and configurationadvanced.h files available on their site. These are the 2 files within Marlin which contain the specific configuration information for a printer. So you should be able to drop these into place within the Marlin 119 source code files and then be able to compile the firmware from source. This gives you the ability to make changes to the printer's behavior. For example, changing the default PLA or ABS preset temperatures or adding a bed leveling probe. So the printer also comes with the usual complement of tools: hex wrenches, a regular wrench, flush cutters, putty knife, and zip ties. It also comes with a USB cable, an acupuncture needle for unclogging a clogged nozzle, a micro SD card and a card reader, and a glue stick to help with adhesion on the plain glass print surface. And there are a few spare parts such as a nozzle, a Bowden fitting, and some screws. It also has an LED mounted to the hot end fan shroud to shed some light on the nozzle while you print. I find this to be a nice little convenience. You know what else is convenient? The printer comes with a generous spool of filament. This looks like a half-kilo spool. Most printers come with just a tiny little coil of filament, not enough to even print the pre-sliced test models on the printer's SD card. So now that you've heard a little bit more about the printer, I want to talk about my experience with it. And please keep in mind, this was a customer return printer which had been ordered by and delivered to someone else who apparently didn't take it out of the box and returned it for a refund or exchange. Also, remember this was given to me by Sunlu, but this isn't one of those buy the printer and give us a review and we'll refund you sort of deals either. I'm completely free to say whatever I please about it, and that's what I'm doing. So with that out of the way, here's what I encountered with this printer. Assembly was both easy and awkward. It was easy because the only assembly you have to do is to bolt the gantry to the base. And it was awkward just because of the sheer size of the parts, but that's really all there is to it. All of the wiring is already done. So I got it out of the box and I attached the gantry to the base, and my daughter wanted to help a little, so she and I assembled the acrylic spool holder. Funny enough, its parts were such a tight fit that it was almost harder to put the spool holder together than it was the printer itself. So with the printer assembled, I gave it a once over to make sure that everything was okay and to make sure that all the moving parts moved like they should. Now I had to adjust the eccentric nuts on the Y carriage wheels. They were a little bit loose, which allowed the bed to kind of move around in ways that it really shouldn't. I also adjusted the eccentric nut on the X carriage just to snug it up a little bit. The wheels on the Z axis seemed fine, so I didn't need to do anything with them. Now, during my initial inspection, I noticed the belts were a bit on the loose side, but I left them as is just to see how it would print without adjusting them. And like I mentioned earlier, I noticed the missing lever on the X-axis limit switch, but I found it rattling around in the box and I reattached it. I set the power supply's input voltage switch to 115 volts and then I plugged it in and turned it on to make sure that it powered up. And it did, and there were no sparks and all the magic smoke stayed inside where it belongs. Next, I homed all the axes to make sure that the motors and limit switches worked properly, and they did. Then I wanted to see if the printer had thermal runaway protection enabled, so I turned the printer off and I tried to power it by its USB port, the way I talked about in a recent thermal runaway test video. But this printer's main board ignores USB power, so I couldn't use that method. So instead, I removed the 3 screws from the front of the electronics compartment and then disconnected the heater cartridge's wires so the printer wouldn't actually be able to heat up the hot end. Then I set a target temperature of 200 degrees. After a couple of minutes of trying, the printer finally decided the hot end temperature wasn't rising, so it declared a thermal runaway error and shut down. So kudos to Sunlu for having this Marlin safety feature enabled. Now, there are a few issues that I ran into, and these have to do with the design of the printer itself. I wanted to make sure that the X-axis gantry arm was parallel to the top crossbar on the printer prior to leveling the bed, so I turned the printer on, homed the axes, and then used the control panel to raise the X-axis arm up to 400 millimeters, which is the maximum Z height. But when it got to the top of its range, the left side of the X gantry stopped short, and the stepper motor made some unhappy noises. So I looked to see what the problem was, and it turned out that the filament runout sensor, which is mounted here, was colliding with a Z-axis support bracket here. So that's a design issue, and it reduces your maximum Z height to between 390 and 395 millimeters. You might be able to work around this by coming up with a small bracket to hold the filament runout sensor a little further out so that it clears this bracket at the top of the Z. Or you could remove the runout sensor completely and do without it. But if I hadn't discovered this issue and I had attempted a 400 millimeter tall print, I would have been very unhappy when the printer messed up right at the end of what could have been a days-long print job. So because the left side of the X-axis gantry ran into an obstruction, the left side was now definitely lower than the right side. I had to turn the printer off and manually turn the right side Z-axis stepper motor to bring the gantry arm back down to where it was parallel with the top crossbar. And I simply checked that with a ruler to make sure that each side of the X-axis arm was the same distance from the crossbar. Once I ensured that the 2 bars were parallel, or at least within a millimeter of being parallel, I was able to properly set the distance between the nozzle and the bed when the Z-axis was homed. In other words, I leveled the bed. So remember those loose belts that I mentioned a while back? They were definitely having an adverse effect on print quality. Now, while there was a little bit of ghosting on the X side of the XYZ calibration cubes, the Y side had some really horrible ghosting artifacts, so I knew I had to tighten them up. Adjusting the tension on the X-axis belt was fairly straightforward, as this is the same design that you'll find on something like a Creality Ender 3. You loosen the 2 screws, use something to pry the idler wheel bracket outward to apply tension to the belt, and then tighten the screws back up. But whereas on an Ender 3 you can perform the same sort of maneuver to tighten the Y-axis belt, there is no way to do that on the Sunlu S8. On one end of the Y-axis belt you have the Y-axis stepper motor, so there's no adjustability there. On the other end of the belt you have the idler bracket, which is held in place by a couple of screws that go into T-nuts in the aluminum extrusion. So without designing a replacement bracket, you have to tension the belt the old-fashioned way. Now the belt has loops on either end of it which attach to hooks on the Y carriage. These loops are normally formed by folding the belt over on itself so that the teeth on the belt interlock, and then you apply a couple of zip ties to keep the loop in place. And by having the belt teeth interlocked, the loop can't slip or loosen. So to adjust the tension on the belt, you remove one side from the carriage, hold the loop in place with your fingers, and snip the zip ties. Then you move the end of the belt loop inward by a few teeth, add new zip ties, and reattach the belt to the Y carriage. So that's what I had to do, but when I got the belt off of the Y carriage, look what I found. The belt loops were formed by folding the belt so the smooth sides were touching rather than the teeth. No wonder that Y-axis belt got so loose. The X-axis belt is like that too. The ends are looped smooth to smooth instead of tooth to tooth, so I'm going to have to fix that sooner rather than later. But once I got the X and Y belts tight, the ghosting kind of vanished. Now I want to circle back to the filament runout sensor for just a bit. I did have 2 other issues with it when I was testing its functionality. The first issue has to do with loading filament. The filament sensor's output is very close to the extruder's input, and strangely, it's not at the same height. So when you're feeding filament into the printer, it comes out of the sensor too low. You need to use a tool to nudge the filament up high enough so you can get it into the extruder. And the second issue is that when the sensor detects a lack of filament, the printer goes into unload the filament mode. And that means that it tries to retract the filament nearly all the way out of the system. But the problem with that is, when the sensor is triggered, the end of the filament is already halfway through the sensor, and it doesn't really want to come back out the other way. So it catches on the inside of the sensor and starts to bunch up. So the positioning of the filament sensor is, again, problematic. It needs to be elsewhere. I don't know exactly where, but right here? That's not the place. So that's it for the issues that I had. Let's move on to some of the test prints. Here are a couple of XYZ cubes that I printed before I tightened the belts. There's just a ton of ringing on the Y-axis and some on the X-axis. Now, here's one after I tightened up the belts. You can see an immense improvement. Oh, and I tested the power loss recovery feature while printing this Calicat. I can find the layer where I turned the printer off and let it sit for a minute before turning it on again, but it's nearly indistinguishable from every other layer on the print. Now, I also spent a fair amount of time tuning the retraction settings. I printed a ton of these little retraction towers, but I got it about as good as I think I'm going to get it. There's some wispy fuzz that's not too hard to get rid of, but overall, it does a pretty good job. Then I printed a few benchies, and I noticed that in its default orientation, with the bow of the boat facing right, there was a little bit of layer curling right at the tip of the bow. And because the part cooling fan blows from the left side of the nozzle, that tells me that parts cooling is mostly adequate, but could probably be a little better. When I rotated the benchy 180 degrees in the slicer so that the bow faced left, the cooling fan was able to keep the layers cool and the tip of the bow didn't curl up. There are a few little barnacles on the back of the benchy, and when I saw those, I gave them a stern glare. So I've still got a little bit of tuning to do, but overall the benchy is in a good place. The little bridging test that I like to print came out really well, and this print is also a stringing test, and the Sunlu S8 was able to do a pretty good job of not having a lot of stringing in between the little test columns. I also printed another Calicat, this time without turning off the power, and it turned out great. And of course I printed one of my favorite test prints, Luby 3D's Aria Dragon. There's a little bit of stringing in between her tail and the column, but apart from that, she came out really good. So those are my test prints. All of them were printed at a 0.2 millimeter layer height with 2 perimeters, 4 bottom layers, and 5 top layers. I'm using a gyroid infill pattern at 15% and printing at 45 millimeters per second. The pink models were printed in AIO Robotics PLA, and the gray models were printed in silver Sunlu PLA+. So now I want to talk about the way that I like things to be on my printers and how they are on the Sunlu S8. These aren't issues, they're just my preferences. First up, the spool holder. I prefer having the spool holder mounted directly on the printer. On printers like this, built of aluminum extrusions, I tend to mount my spool holders on the front left corner, and I tend to have that angled a little bit forward. This doesn't take up much room at all on the left side of the printer. It keeps an extra kilogram or more off the top of the gantry, and it keeps the overall height of the printer down. Plus, it's out of the way of any printer wiring. So as nice as this clear acrylic spool holder is, I would have preferred one like I have on my Ender 3 and Ender 3 Pro, and I would have mounted it on the printer the same way. Then there's the power switch and the power socket. They're in an odd location, as I mentioned earlier. I would prefer to see the power switch on the right-hand side of the printer's electronics enclosure instead of at the back of it. While the printer is in operation, the bed can move rather quickly. If there's an emergency during printing and you need to turn the printer off, you have to place your hand in an area where the bed can reach. So there's a risk of injury to your fingers or hands. The printer's power switch should not be located in an area where moving parts can injure you while you're attempting to turn it off. In the event of an emergency, it would be much easier to turn the printer off if the power switch was easily reachable and not in the path of moving parts. And with the power socket all the way at the front of the printer, I think the included 5-foot-long power cord is just a bit short. This printer should have included a longer cord. Now, let's talk about this plain glass print surface. I gotta say, I am spoiled by my Wham Bam Systems spring steel flex plates, and Printing on plain glass seems so last decade. I mean, yes, Sunlu gives you a glue stick, and yes, it does work, but if they had to use a glass surface, it would have been much nicer to have something like an ultra-base style print surface. At least that would release the print once it's cooled down. From an ease of use standpoint, I would almost rather have seen something like the thin fiberglass board with a textured sticker sheet on it that my Ender 3 came with. While it's not as flexible as the Wham Bam spring steel sheets, it's far more flexible than a sheet of glass. So at the very least, you can get the edges of the print released before trying to get that scraper under the print to remove it. Okay, with that out of the way, I think I've used the Sunlu S8 enough that I can go over some of the pros and cons. First, the pros. Fast, easy assembly. It really is as easy as taking it out of the box and bolting the Z-tower into place. Every single electrical connection is already done. Motors, in-stop switches, filament sensor, everything. It has a huge print volume. This thing is huge! I'm going to have to print something epically large on this thing just because I can. And you know what? I'm open to suggestions. I've pinned a comment to the top of the comment section asking what you think I should print. Reply to that and let me know. I'll take a look at the suggestions and then pick the one that I like the best. The thermal safety features are in place, and I verified that thermal runaway protection was working as expected. With properly tensioned belts, the print quality is good, and it has an excellent feature set for the price. This printer can be had from various resellers online for about $300. You can buy direct from Sunlu, but it'll cost a little bit more. But for that money, you get a printer that's dead simple to set up and that you can print huge models on. With the power loss recovery feature and the filament runout sensor, you can print something large and not really have to worry about print failures due to a power outage or running out of filament. Now, the cons. That plain glass build surface is just not as user-friendly as something like BuildTack. It can be more of a challenge to get filament to stick. And the large build surface can be more of a challenge to level. Now, it also had those loose belts, and there's no way to easily tension the Y-axis belt, and that gave me some poor print quality out of the box. The Y-axis belt couldn't hold tension because the ends were looped smooth to smooth instead of tooth to tooth, and this allowed it to slip. The placement of the filament runout sensor causes the X-axis gantry to collide with the bracket at the top of the Z-axis. And the power socket and power switch are awkwardly placed. And the printer is loud overall. The fans are loud even when the printer is idle, and the stepper motors are loud during printing. With the pros and cons done, I would like to offer a few suggestions to Sunlu for improving the S8. A longer power cord should be included. Since the power socket on the printer is up at the front, you automatically lose about 2 feet of cord length. The printer includes a 5-foot long power cord, but having an 8-foot long power cord would give you a little more freedom over where you can place the printer. The power switch should be moved to the side of the electronics compartment. In its current location, there's a risk of injury if you need to perform an emergency shutdown of the printer while it's actively printing. At a minimum, position the filament sensor a little further out from the extruder so that it clears the threaded rod support at the top of the Z-axis. An optional plug-and-play bed probe would improve the new user experience, and by plug-and-play I mean having the wiring already in place at the printhead, and having a bolt-on touch probe like a BL Touch to sense the subtle hills and valleys of such a large print surface. Now this should also include either automatic detection of the probe in firmware or a simple user selectable option on the control panel to tell the printer that the probe is installed. Also, use a power supply with a thermally controlled fan to reduce idle noise levels. And use silent stepper drivers instead of the old 4988 style drivers. Now I realize that the silent feature set is often used as a premium bullet point, but surely by now, the silent drivers are in such great supply that the component cost is comparable to the standard drivers. Also, provide an easier way to tension the Y-axis belt. There's really no adjustability to it. Having to turn the printer on its side, pull the belt from the Y sled, snip zip ties, adjust the belt length, replace zip ties, and put the belt back on the Y sled, that doesn't cut it. There needs to be a tensioning mechanism. And finally, raise the quality assurance a notch or two. The belts on the X and Y axes should never have been assembled smooth to smooth. Doing so allows them to loosen over time, and make sure that the wheels on the X and Y axes are snug to the extrusions. The bed was pretty wobbly, when I unbox the printer. So with all that, with the good, the bad, and the potential areas for improvement, would I recommend this 3D printer? Well, I've said this before, and I'll say it now. It depends on the target audience. The Sunlu S8 3D printer is astonishingly easy to assemble. It is far less complicated to build than the Ender series, but new user friendliness is about more than just ease of assembly. It's about ease of printing, and some of that has to do with the print surface. Printing on plain glass can be a challenge. Printing on build tack or something like it gives you a much greater chance for success, and printing on a surface like that, attached magnetically to the bed, which can then be easily removed from the printer and flexed to remove a large print, well, that just makes printing a pleasure. New user friendliness is also about being able to easily find help when you're, well, new to 3D printing. It's about being able to find the resources that you need to solve problems that you may experience with the printer. But at this point, the new user support infrastructure just isn't there. The support forum on Sunlu's site is very low traffic, and the Sunlu Printing Facebook group is for all Sunlu products, so it covers both their filament and their 3D printers. And it's a private group, so you need to ask to join. So while someone new to 3D printing will have an easy time assembling the Sunlu S8, the community-based support resources, such as public Facebook groups or even just Google searches for issues with the printer, are still in their early stages. Of course, if you have an Ender 3, you sort of have the opposite problem, information overload and sometimes contradictory solutions. But the point that I'm getting at is that with something like an Ender 3, you can find a ton of solutions for Ender 3 issues. With the Sunlu S8, a Google search for Sunlu S8 hot end gives you 2 videos and several places to buy the S8 online. A Google search for Ender 3 hot end gives you a whole treasure trove of useful and, to be fair, not so useful results. So even though the Sunlu S8 is remarkably easy to assemble, and even though you can literally be printing 15 or 20 minutes after taking this thing out of the box, I wouldn't recommend this for someone brand new to 3D printing. But if you already have some experience with 3D printing, maybe you have a smaller 3D printer and you're looking to get something bigger, this may be a good printer for you. It's got a really big print volume at a really affordable price. Now, I've only had this for a couple of weeks, so I can't say how the printer holds up in the longer term, so keep in mind these are my initial impressions of the printer. But if anything goes south with it in some major way, there's likely to be a video about it. So if you're interested in this printer, I have a link to it in the description. Now, I also have a link to the Sunlu 3D printing group on Facebook. At this time, it's a private group, so just ask to join when you follow that link. And Rebecca from Sunlu told me that you can send her a message on Facebook to request a discount code. She goes by Rebecca LQ, and she's one of the group admins. Or you can message the Sunlu 3D account on Twitter. I don't know how long that offer is valid, so you'll have to get with her to find out. Well, my 3D printing friends, that is about all the time that we have for today. And now that we're at the end of the video, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end. And thanks for all the likes, comments, and shares. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great. And if you'd like to help support the channel, check the description for ways that you can do exactly that. And now don't forget, whether you're interested in buying things that were featured in this video or just buying things online in general, there are links in the description that will get you to the right place. Now, I've got some other videos here that you might want to take a look at. Also, please consider subscribing if you haven't already done so. Subscribing is absolutely free and is an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.